Silicon wafer production process. Silicon wafer manufacturing process can be divided into two stages, which is pulling single crystal ingots and slicing and grinding the silicon wafers. Pulling single crystal silicon ingots are also called as CZ method. In the CZ method, polycrystal silicon nuggets are placed in a quartz crucible, which is set in a graphite crucible surrounded by graphite heaters in the crystal pulling chamber. These nuggets are melted by heating in an inert atmosphere under vacuum and then pulled slowly using a seed crystal. Single crystal silicon ingots. Single crystal silicon ingots, when completely grown, have a shape such as these. A crystal ingot for 200 mm wafers weighs as much as between 60 to 100 kilograms. Peripheral grinding. The ingot is cut to the specified length, and the peripheral is ground to the specified diameter. Either an orientation flat or a notch is added to a part of the peripheral to indicate the crystal orientation. The shape of the ingot following the completion of the peripheral process can be seen in the diagram. The diagram shows an ingot with a notch. Slicing. The ingot is attached to a graphite holder, and wafers are sliced one by one from the ingot using a rotating diamond inner peripheral blade. Beveling. Peripheral rounding. The periphery of a wafer is ground with a diamond tool to attain the required product diameter. Then, it is also ground further and beveled to a circular shape. Lapping. Double-side lapping. Wafers are set in a carrier which spins between two rotating lapping plates. Both surfaces of the wafers are lapped as abrasive grains are fed. Etching. Double-side chemical polishing. Wafers are placed and etched in a holding jig that rotates in an acid-containing etching solution to completely remove the damaged surface resulting from the previous lapping. Heat treatment to remove unstable donors. Heat treatment is applied in a diffusion furnace. Oxygen-derived unstable donors and type impurities generated during crystal pulling are decomposed in order to restore the originally intended specific resistance. A wafer bonded to a plate is pressed against the surface of a rotating plate covered with a polishing cloth. It is polished to a mirror surface by a combined mechanical-chemical action using abrasives. Wafers are physically and chemically cleaned using ultra-pure water and chemicals. Inspection of the wafer's appearance is conducted using a high-intensity light source. Additionally, inspections are conducted to assess the flatness of the wafer, its specific resistance using testing equipment, and to count the number of particles adhered to the surface. Wafers are packaged in a clean shipping case and sealed in a special moisture-proof bag. Wafers are placed in a shock-absorbent shipping boxes for protection against damage caused by shock.